Howdy homies, James here with Rewind Electric. Got a couple things going on today, so let's just get right into it. First, let me get these out of the way. I got some beautiful pickups that I'm working on here. Some of these are going out to a very prominent builder of Les Paul shaped things that you probably have heard of. And others are overrun. I think there's a couple customer sets in there. Some of that stuff might find its way onto reverb. Could be some extras. Move these out of the way. First thing I wanted to do, we'll knock out the easy thing. In this box, there should be a selection here of new old stock Blackburn factory Mullard EL84s. They will need to be tested. Never trust a seller, including a dealer online, to say that, you know, a thing is new old stock. It is, and that it's unused. So check this out. I've got this camera in here, and I've got it set up on a gimbal that's supposed to follow me. It's not doing a great job. I might have to tell it to stop that. Okay, maybe like that. All right. As I was saying, never trust a seller, no matter what their feedback is, that you buy on Reverb or eBay or whatever. And they tell you tubes are new old stock, and they tell you tubes are new in box, and they tell you they're matched. Most of the ones that I buy are not. Now, some of that is up to interpretation on what did they use to test it with, at what voltage, at what bias current, bias voltage, you know, the conditions in which they were tested. So maybe the tubes matched at 100 or 200 volts where they tested them, which is not uncommon of a testing voltage, especially for older tube testers. But maybe they don't match at all when you get them up to 350, 400, 500 plus volts, where you're actually using them in an amp. So in that case, who cares what they test on the tester? Are you going to run them in a tube tester, or are you going to run them in an amp? It only matters if you run them in an amp. So that's why I don't have a TV7, because I believe that they test at 250, 270 something plate volts maximum, and I don't have any amps that run that low. I don't think you do either. Not on output tubes, you know, preamp tubes, perhaps. I don't know what voltages TV7s test preamp tubes. Maybe you can tell it to do that. I've never had one. Worked with them, but I don't remember. Okay, so there's those little beauties. Now, let me grab the tester. I'm already foreseeing a couple of problems. One is that I have to get adapters to run EL84s in that. Okay, that wasn't such a problem because there they are. Woo! I was able to find them. The other problem is I got a bunch of camera gear plugged into my outlets, and I don't have all the voltages that I would like. I'm sorry, all the outlets that I would like to plug things in here at the moment. I think I know what I'm going to have to do. I'm going to just plug this into the bench power supply here. Run it off the variac, basically. Nice. Clean, controlled power. So, okay. Let's pop these adapters in first. So these are the adapters. They just change the standard octal socket type down to the smaller size that we'll use with the EL84s. Never used these adapters, but I knew, see, EL84. There might even be some pin manipulation happening in those sockets. I could tell you real quick. Let's see, let me think about that. So an EL84 has no connection on pin 1, control grid on 2, cathode on 3, heaters 4 and 5, no connection on 6, 7 is the anode, no connection on 8, and 9 is the screen grid. So that is, yeah, that's going to be different from, yeah, that'll be different from other octal sockets. For one thing, there's 9 pins. That's going to make a difference, right? All right, let's have a look at these. Let's see if we can, maybe I should use this camera. And there it is, the factory code. I don't know if you guys can see that. RX3 B4H4. So B is Blackburn. The RX3 is the revision number. And I don't know what that means for EL84s exactly. I don't know if that means that they were subject to the same revisions as the XF3 EL34s. I would be more familiar with that. But I could say by the logo that that's possible, because the logo of the same time period. Now, I see a little bit of, I don't know if you guys can see that. There's like a little bit of a ring around where those holes in the plate are on the glass. And that doesn't necessarily mean that these were, like, you know, worn and used. That could be an artifact of when they did the flashing. I don't know. But it could mean that they were used. That doesn't really matter if they were used or not. These are awesome tubes. What matters is how strong they are today and if they match. I should have checked the code on that. Let's see, yeah, BH3, RX3. This one, B4H4, RX3. Oh, is that what that was? This one has the Made in Great Britain printing right over it. Oh, let's take it out and look to be complete. RX3, and then it's that other part that's quite hard to see. B4H3, whereas this is a B4H4. Okay. Probably ought to have cleaned the pins before I stuck them into my new adapters. And I might have read that code as well. This one, RX3B4H4. All right. Now, the Maxi Matcher 2 wants to be 325 plate volts and minus 14 volts on the bias for an EL84. So those are fairly light settings. And let's, oh yeah, we gotta fire this up, but we gotta fire it up. Fire up the bench supply. And we'll give this bad boy a perfect 120 volts. 121.9. Yeah, that's not what I said. There we go, 120. That takes some time to come up to speed. Okay, while that's doing its thing, let me show you something else. Okay. This is a Roland SDE3000A. So, what did Boss call their new like Van Halen reverb pedal? SDE500? I forget. Maybe it was an SDE3000. So what that is it's emulating these guys. Two of them, maybe four. There might actually be four in there, but I think you need two for stereo, but I think they actually have four parts, not in total. And then some extra control and presets, and I think probably longer delay time. It would make sense. And so that's like I don't want to call it a reissue because it's not. It's a little pedal and it's got a bunch of other stuff going on with it, but it is made to sound and act like those. Okay, that guy, that's an original from the 1980s, and I have another in the other room and some more on the way. These are, well, these are about, I hate to say the price because it's going to be dated, but but at the time this video was filmed, these go for about $550, $600, $700 US for the 120 volt version. These are the 100 volt version. Does it say that on there? I can't see it. Yes. AC 100. You see that there? 100 volts, 50, 60 hertz. These were actually made in Japan, as all Roland products were at the time. And those are made to run on the 100 volt power that Japan has. I did say 100, didn't I? Yes, 100 volts. Japan is a very low voltage power grid country where they run things on 100 volts. So those are made to run on 100 volts because they're made to be used in Japan. There is some minor difference between those and the 120 volt version that was made for sale in the US. Those differences are one capacitor inside, of which I have a bag of 20 of these here, and which primary tap on the internal power transformer is connected. This is not a tone bearing part, it is a safety part. So these are X2 rated safety capacitors, and they are of a different value as well as the safety rating than what is in the Japanese model. If you look at, back then gear was published with full schematics, parts lists, everything was detailed out for you so you could see what voltage rating and what capacitance rating every part in it is, what the ICs were, part numbers to order from Roland. Now you don't get that. Now you get like, send it to your Roland authorized service center and they'll either throw out the broken board and replace it with a new one, or just, you'll be charged for repair of a jack if they do it, or you're basically throwing stuff away, be it a part or the whole unit, because they're not made to be serviced like those were. So I have the documentation in the service manual, and I found out the differences between the two, and it's fairly easy to convert that over to a 120 volt unit, and you are dealing with the mains voltage, the high voltage part of it, and you're dealing with safety features in there. Now, as I am doing that, I will also be putting on a 3-prong cord, because these came with 2 prongs, and they're not polarized either, which is naughty, because although both of these are switched with the power button, only one is fused, and that's technically not right, because then you don't know, depending which way you plug it in, your hot might be fused or your neutral might be fused. And I ain't an electrician, but I hear you're supposed to have the hot fused. Now this has a ground, a location to ground it manually, and an external ground lug. And in household power, your ground and your neutral are tied together, I believe, at the junction box at the breaker panel. There should be no potential between ground and neutral. Sometimes there is. Also, please take everything I'm saying as if I'm like a guy who's a tinkerer, hobbyist saying it. I don't really know what I'm talking about, because that is true. I feel that being the case with a non-polarized plug and an independent ground, you could have some potential trouble there. Anyway, I'm going to put a 3-prong on there with a bolted and soldered lug to the chassis, so that it can be brought up to speed, modern safety. And while I'm doing that, I would probably shorten the cord too. Those things are going to go in a rack, so I don't see why, who needs a 10-foot, 12-foot cord? I will probably have a 4-foot cord, maybe a 3-foot cord. I've been in these before. I didn't pay attention. It's possible that there's room in there to put an IC socket, which would be mighty handy, because then, if you've got 2 of those sitting in a rack, which I will, and that's how anybody who wants to run stereo is going to do it. And you can link them together. It's got a CV gate, which, if you know what MIDI is, CV gate was back yonder, previous to MIDI, was the way of controlling things. And you can link the 2 together for your LFOs and your stereo effects that way. And it would be kind of neat to have an IEC back there, and then you could just have one cord go to like a Y and plug in both of them, bam, into the power conditioner of your rack or whatever. Let's jump back to these here EL84s for a moment. I think it's Sharpie time. So let's see, how are you doing up here, other camera? My wife's iPhone doing camera duty up top. I wonder how the audio is going to be. I have a nice Rode boom mic on top of that camera, and I'm just recording iPhone audio here. I think what I really need to do from watching my other videos, and like, I'm not a video guy, I do this and this is an extra. I don't do that and this is an extra. So I'm kind of learning as I go here. I do know a lot about sound and recording though. So I think what I should do is either hang a shotgun like over my bench so I can pretty much get the whole room, but there still will be some proximity effects. I think I need a lavalier for doing these little like voice. I don't know what you call this. Was it a tutorial? It's just me like slowing down my workday so you guys can enjoy it. I hope somebody enjoys it. I think this stuff is neat. I would watch it because I am a big dork and I watch things like that. So these tubes ought to have been fairly well warmed up by now. I can't quite tell you how long they've been sitting in here. Maybe I can if I look at this. Yeah, probably a while because that video's been going. So let's look at the plate current first. So first tube's drawing 29.2 milliamps. Second one's drawing 34.6, maybe 34.5. It was going down. 27.9 on the third. 27.6 on the fourth. So the third guy is the only one that's like slightly off, and I think it's fine. I would be happy to run that myself, and it was going in the correct direction as it warms up further anyway. And that one is the one that has the BR ITIAN. What does that say? That says Great Britain. H3, that's the H3 coded one, whereas the others are H4s. So that one is kind of an outlier, but only slightly. Like, it's 5 milliamps off. And progressing in the correct direction. So I'm okay with that. I'm gonna run it. If it sounds good, I'm gonna run it more. Also, because we're talking about 4 tubes, not a pair of tubes, that difference is going to be cut in half. Especially if you pair it up with, so say this is the one drawing the highest current. If you pair it up with the one drawing the lowest current, which is this guy right here, then this pair and this pair will actually draw a fairly even amount of current. However, plate current draw is not everything in this world, and nor is the AC30, JMI AC30 that these are going to go in, going to run at 325 volts, I don't think. Don't know as much about 84s. We'll see. Transconductance. This is the amplification factor, basically, when you put it in an audio amp. So, 7.3, we're going backwards 4 to 1, 732, 745, 8.2, 7.7. Those are all numbers that I am definitely happy with. Let's see, this one is pushing 8.2. Kind of makes sense. That's the lowest. 728, I believe. Yeah, great. So the transconductance actually matches the current draw in this case. We're highest lowest. So this will be a pair, and then this will be a pair, and these are fairly even to each other, and the two pairs will be fairly even to each other. So yeah, I'm super happy. That's good. You know, some guys like, you know, within like a milliamp or something, but that's at one specific setting. You change the settings around, you put them in an amp, and all this is also at idle, and that's like, that goes away. So I don't see any reason to match tubes quite that close. If you were matching triodes in a, if you're matching, triodes in like a 12AX7 for a phase inverter or a stereo section of an amplifier where you want your right and left in a hi-fi to be fairly identical, like, okay, that makes sense. But in the output section of a tube amp, like, oh no, there's a little bit more character and charm there. Terrible. No, it's good. As long as you're not balanced where you're hurting anything, and as long as you pair them up wisely. So the thing to do, happy here with these figures, definitely. But the thing to do still is when you put them in an amp, you look at those numbers again in the amp under load, and you maybe reevaluate. Maybe you swap two of them. You make sure that they're all like, you know, you're happy with them again then, but maybe you swapped it. Maybe the two pairs are a little, you know, you have a different partner for one of the tubes or something. So here, I'm just going to write these down. And we'll start with, we'll go 7.71 MA. 9.1 MA. Did I do something wrong there? Yes, I did. This is the first one. That's one. 29. 9.3 milliamps. 33 milliamps. They're actually getting closer now as they warm up. 32.9. See, it's going. It's actually getting pretty close. 27.7. Tubes are not a static device. I mean, I guess they might be. If you're running a diode, it could be something like that. 27.1, but audio tubes are a dynamic device. They are going to vary under all the different frequencies and levels, heat, other conditions and fluctuations that they experience in the amp. Okay, transconductance, 7.7. Micromos, that's what they call that. And I just put GM, which is a short for transconductance, I believe. 8.03. Oh, 8.02. 03? Okay. $7.42. $7.26. 25? 25. Sweet. All right. So you can fire that down. You let them cool. Shut the bench supply down. Yank the plug. All right. I think I'm going to cut this one here. Because it'd be too long and annoying and weird to have like two very different things and testing those tubes and then also working on the Roland SDE3000As. So yeah, short ending. Sayonara. Have a good one. See ya.